odd functions. Even functions are functions that are symmetric about the y-axis. So if you think about f of x equals x squared, just the parent function of the quadratic. It's just going to be a little sketch of it, but you've all seen it before. And the left side, what's on the left side of the y-axis, is just a reflection of what's on the right side of the y-axis. This little attribute, this little property of this function, makes it an even function. It's symmetric about the y-axis. And so if you think of what makes that true, if I plug in, let's say positive 2, what do I get? I get 4, right? Because this function tells me to square it. If I plug in positive 2, I get 4. What happens when I plug in negative 2? It's still positive 4, right? So it doesn't matter on even functions. If I plug in the positive x value or a negative x value, I should get the same y value back out, right? So what does that say? What does that mean in function notation? Doesn't matter if I plug in the positive x value or the negative x value, I should still get the same answer back out. So to check, everybody understand this function notation? Plugging in the positive version or the opposite, the negative version, and then they should be equal to each other, right? I plugged in positive 2 and got 4, plugged in negative 2 and got 4. So if a function is even, then this should hold true. Now, is that the case for every quadratic? If you recall from Algebra 2, we would have the transformations, and I could slide my quadratic over in such a way. Would it be symmetric about the y-axis now? Grossly not, right? And so not every quadratic is going to have this property, and so the way that we check it, we'll use this right here. So I want to determine So to determine if f of x equals x squared minus 2x plus 5 is even, or an even function. So I have f of x. If it's even, then f of negative x should equal the same thing that I have here. So let's figure out what f of negative x is. So I'm plugging in negative x for x. So that means I'll have negative x squared, in parentheses, right? I'm squaring this whole thing, minus 2 times negative x plus 5. Simplifying that, negative x squared is positive x squared. Negative 2 times negative x gives me positive 2x plus 5. So now compare what we got from f of negative x to what we had with our original function. Are they exactly the same? No, right? This has a minus 2x, this has a plus 2x. They are not the same. So f of x does not equal f of negative x. So f of x is not even. Alright, so let's look at an odd function. So odd functions are symmetric about the origin. And so another familiar function maybe not by my picture, but this is f of x, a rough sketch of f of x equals x cubed. And if you look at what's in the third quadrant, if I were to reflect that, I would get what's in the first quadrant, or rotate it. I would get what's in the first quadrant. So this is symmetric about the origin. And now here, with my cubic, if I plug in +1, I should get +1. And if I plug in -1, what's -1 cubed? -1, right? So if I plug in the opposite x value, I should get the opposite y value, right? So we look at that as if a function is odd, then negative f of x should be equal to f of negative x, right? I should get the opposite value than what I get if I plug in the opposite x value. Does that make sense? Okay. All right. So in the same manner, let's go ahead and let's show that x cubed is an odd function. And so in order to show that, I need to figure out what negative f of x is, and I need to figure out what f of negative x is, and see if they equal each other. So negative f of x, I'm just multiplying my function by a negative, so I get negative x cubed. And f of negative x, like we did with the even function, I'm just plugging in negative x for x. So I get negative x, make sure you put parentheses around it, negative x cubed. What happens when I cube a negative number? It's still negative, right? A negative times a negative times a negative still gives me a negative, so negative x cubed. So negative f of x is negative x cubed, and f of negative x is negative x cubed. So they are, in fact, the same, right? Negative f of x does equal f of negative x. So f of x equals x cubed is odd. It's an odd duck. It's an odd function. Alright, so I want to determine if this function is even, odd, or neither. Because a lot of functions aren't going to be even or odd, right? It's just a special handful that are one or the other. So I want to determine if my function is even, odd, or neither. And so to determine if it's even, recall, I need to show that f of x is equal to f of negative x. So I need to know what f of negative x is. And then to show if it's odd, I'm going to need to know what negative f of x is and what f of negative x is, right? Oh, you can't see that. To determine if it's odd, I need to know what negative f of x is and what f of negative x is. So I need to figure out negative f of x, right? And I'm going to compare f of x to f of negative x and negative f of x and figure out if it's even, odd, or neither. So f of negative x is going to be negative x squared minus 5. Negative x squared is x squared minus 5. And negative f of x, I'm just multiplying the whole function by a negative. So I get negative x squared plus 5. These are the things that I need. So if it's even, then f of x should be equal to f of negative x. So let's compare the two. F of x is x squared minus 5, and f of negative x is x squared minus 5. Are they the same? Yeah, very much so, right? So this function is even. For kicks and giggles, let's check and see if it's odd. So if it's odd, then negative f of x should be equal to f of negative x. Negative f of x is negative x squared plus 5. F of negative x is x squared minus 5. Are they the same? No, they're opposites of each other, right? But that doesn't do any good for me. So I'm going to put a slash through that. Those two things are not equal. So this is not odd. But f of x is even. And if we got something that was not true for either, our answer would just be neither. Okay? Questions?